Hello, my name's Tim Shoebridge and welcome to this, which is the fourth video in my little mini-series about the Waldorf Quantum. Now this video is going to be all about the waveform generator, which is one of 4 different algorithms that are available to you in each of the digital oscillators inside the Quantum. Now the waveform generator, its duties are to generate classic waveforms, the kind of things you'd expect to find in any subtractive synth. So we're talking about sine waves, triangle waves, sawtooth, pulse waves, etc. So this should, in theory, be quite a brief video. However, Waldorf being Waldorf, there are a couple of really nice little surprises up their sleeve with this particular algorithm, and we'll get into that in a second. So I really do hope you enjoy this video or find it in some way useful or interesting. Thanks very, very much for watching. Okay, so I'm going to start with an initialized patch. Which by default is a wavetable, so we'll switch it to waveform, and here we are with the waveform generator. So we have a shape control here on the top left, and we've got the display. I have to say, out of all of the different displays that are available, this is kind of the most boring of them all. It's not animated at all, unfortunately, which is a shame. But maybe that can be changed in the future, make it a bit more exciting. However, we get a very clear view of our waveform, and by default it's a sawtooth. So if I just go through the different shapes here, we've got sine, we've got triangle, we've got square, and then we've got 2 noise sources here. We've got pink noise, which is a kind of sort of like low pass filtered white noise, and then we have white noise. Now I was a little bit disappointed when I saw that there's noise there, because that means that if you want to add some noise to your preset, you're going to have to sort of like use up one of the oscillators to do that. However, there are some benefits in having the noise here in an oscillator, and I'll show you that in a second when we get onto this control here called the warp control. But if I just go through and just play the sounds of these waves, because I mean they're just as you'd expect exactly. Sawtooth, sine, triangle, square, pink noise, white. Okay, so like most modern, I'd say most modern synthesizers these days, as well as providing a set of classic waveforms, they also have some ability to change the shape of those waveforms, and on the Quantum it's called warp. And I'll go through each of the waveforms in turn and show you the effect of warp. You'll see here that warp by default is at 50%, so it's like a middle position, so you can move to the right to change the waveform and to the left, and obviously it's a modulatable adjustment as you'd expect on a synthesizer. So let's go with the sawtooth first. I'll move it to the left, see what happens, and then move it through to the right and see what happens. So you'll see that the waveform is starting to split, which is doubling the frequency basically, so taking it up an octave. So it's a double saw, kind of super saw-y kind of thing. Although a super saw is sort of detuned sawtooths, but so that's going left, and then as we go right, you'll see it splits, and it's starting to turn into a square wave. Now, as rather than use this control, which I don't know if you can hear it or not, but it's a very clicky control. All these controls are. I'm going to use one of the controls here on the panel, which is dedicated to the warp effect, just because it's silent and smooth. All right, let's move on to the sine wave. So moving it to the left, it's skewing the waveform, and at its furthest extent, it's kind of a smoothed off, curvy ramp wave, reverse sawtooth. Back to the center position. And then it's warping it the other way. nice sound actually. Okay, on to the next one. Triangle. Again, it's skewing the waveform, and then towards the very extremes it's like adding these spikes. Then square. So it's changing the pulse width. It's not quite going through 0. But as well as changing the pulse width, it's actually sort of like moving the whole waveform either into negative territory or into positive territory. There's a bit of a weird flip there with the display in the middle. I don't know whether the actual wave is flipping like that, or whether it's just they're reusing the animation, flipping it so that they can use it left and right. I'm not sure, but it's a little bit disconcerting to have that flipping going on. But it's not affecting the sound. Okay, now let's get on to these noise sources, because they're interesting when it comes to this warp control. So first we've got pink noise. Let's go to the left. This lovely self-resonating kind of sound, which is actually tracked to the keyboard. And then finally, white noise. That sound really begs a little bit of reverb, doesn't it? Let's just add a bit of reverb, see what that sounds like. Okay, so back to initialize patch again, and let's just talk about this little parameter down here before we get into some of the more weird and interesting parameters that we've got here. So we've got here something called phase, and by default it is running, which means it is constantly generating the waveform in the background, whether or not I'm holding down a key or not touching the keyboard at all. And this is mimicking the way that analog oscillators work. They're constantly generating a waveform, and as you hit the keys, you'll sort of jump in to that waveform at whatever point it happens to be being generated at the time. That can cause some problems. It can cause some problems, especially with lower bass notes. You can get some sort of like phase cancelling issues with your sound versus other sounds that you're mixing with, and you can also get some sort of clicky stuff going on with sine waves. Let me just see if I can create that for you. So if we go with a sine wave, it's on running, and let's play some low sine waves. You can hear that little click at the beginning. But if we change the phase to reset, and what reset does is it makes sure that the waveform starts at exactly the same point in the cycle each time you hold down a note, and it eliminates the clicking. I think it was Bob Moog that famously introduced this reset capability in his bass synths. Okay, so before we get on to these three parameters here down the right hand side called count, detune and stereo, I just want to briefly touch on the stereo capabilities of this synthesizer. I'm going to cover that, or I plan to cover that in a future video, because there's quite a lot to get into, and we need to get into discussions about analog versus digital filters and routing of the signal and stuff like that. I'm not going to cover that now, but what I want to say is that each of the oscillators is fundamentally stereo in its nature. You can generate a simple waveform, but you can also be playing back a wavetable, which can be a stereo wavetable. You can be playing back a sample, which can be a stereo sample. So the oscillators are inherently stereo in their wave generation capabilities, and you can pan each of the oscillators within the stereo field. If I go to the control tab here, now this is the same no matter what algorithm you're using. We just happen to be using Waveform here today, but you can do it with any of the algorithms. We've got an oscillator pan control here, so if I hold down a note, I can choose exactly where I want that oscillator to sit in the stereo mix, as long as I've routed it correctly, and I don't want to get into that right now. So I just wanted to mention that in terms of the stereo capability of the oscillators, because when we look at these three parameters here on the right hand side, we start to talk about stereo. Okay, so now let's talk about the three controls here down the right hand side. We've got something called count, something called detune, and something called stereo, and by default with an initialized patch there's a value set for detune and stereo, but the count says 1.0 kernels. So what is this count and what are these kernels? Well, if we turn up this value, we'll see that it goes all the way from 1.0 to 8.0 and everywhere in between. And the reality is that this waveform generator is actually 8 waveform generators in one. Kernel, by the way, it's a term used in computing, in IT, in computer design to sort of like represent a single core computing component within a CPU of a computer. So it's something that is doing the work, and we've got 8 waveform generators doing the work inside this one algorithm here. It's a bit weird that we've got a decimal place. I mean, okay, I can appreciate that there's 2 waveforms, and that is 3. But what about 2.5? Well, I had to read the documentation to figure this out. And basically what it says is if you're using sort of like a not a round number, then say here, like we've got with 2.5, what it's going to do is it's going to take 3 waveforms and it's going to mix that third one in to give you the 2.5. So there's an awful lot of fine control here in terms of the number of waveforms that you can play at any point in time. So what does it sound like? So this is a note held down with 1, 2, 3, 8. There's not a massive difference in the sound between 2 waveforms and 8 waveforms, but that's because we're not playing around with these other parameters very much. So you can hear that there is a sort of, definitely there's a multiple waveform thing going on there. There's a slight phasing between them. There's a slight detune compared to. And that detune is this control here, and by default it's set to 6.42, which is a very precise number. You can go all the way down to 0. Up to 100 cents. And what it is doing is it's taking those waveforms that it's generating, all 8 of them, and it is spreading them very slightly around the center frequency so that the whole sound still sounds in tune with whatever you're doing, but we've got that sort of detune spread to give the sound a really fat kind of super saw kind of sound, in this case with a sawtooth. And we've got something here which is stereo, and by default it is set to 90 degrees. So as well as spreading those waveforms out and detuning them very slightly if you want to, you're also able to spread them across the stereo field. And 90 degrees is a small amount of spread by default. So if I take the control all the way down, it's at center, which is just everything's in the middle. And then all the way at maximum is that the waveforms are going to be either left or right channel, and obviously it's going to sort of like balance it. So here we're going to have 4 on the left and 4 on the right. So that would be a good reason to have a decimal place here in the number of waveforms, so you'll just get a little less of an exact sort of stereo balance. So in most synthesizers, you know, if you take the Novation Peak as an example and the Summit, and you take Dave Smith Instruments synthesizers, they have the ability to take a whole voice once you've set up all your oscillators and your filters and your envelopes, your LFOs and everything, and you're playing a sound. They've got the capability of taking those voices and then allowing you to stack them in kind of unison mode if it was in a monophonic setting, but otherwise stack voices polyphonically. It reduces the whole number of voices that you've got available to you. It means that you no longer have an 8-voice polyphonic synth. Maybe you've got 4 if you stacked 2 per voice, but it gives you that ability to then stack those voices, detune them and spread them to get a big fat sound. Now the reality is that with the Quantum you can do that. You can do that at the voice level. You can stack voices, you can spread them, and you can detune them exactly the same way as you can with those other synthesizers. But this particular synthesizer can allow you to do it inside each oscillator, and that's a really, really big thing. I just want to drive home this point by showing you now a little presentation I put together to graphically display what I'm talking about. Okay, so here's a little presentation I put together, and what I want to do with this presentation is just literally compare the Quantum against a couple of other synthesizers to show you how this whole waveform detuning and spreading works in those other synthesizers, to show you really where the Quantum fits in with those. So we'll start with the Novation Peak. The reason I'm choosing the Novation Peak is because in some ways it's similar to the Quantum, as in it's a digital hybrid synthesizer. It's got 3 oscillators per voice and it's got 8 voices in total, so 8 voice polyphony. So let's start off with the Peak. Here's an oscillator. Here's my representation of an oscillator. Each oscillator can play one waveform at any point in time, whether that's from a wavetable or whether it's a sort of a classically generated waveform. We have one waveform per oscillator, and we have 3 oscillators in total. So in terms of a voice, a peak voice, we've got those 3 oscillators, we've got the filter, we've got modulators, and by modulators I mean envelopes and LFOs, and that's what creates our voice. And with the Peak, as I said at the beginning, we've got 8 voices in total, which means if we play one voice per note, we've got 8 voice polyphony in total. And with the Peak, lots of flexibility. You can stack those voices either polyphonically or monophonically in unison mode. And so here in my example, we've got 2 voices per note being played. It reduces the amount of polyphony down to 4, but the reason you do that is you want to spread those voices, detune those voices, and create really big fat sounds. So that's the Peak. Let's go and look at the numbers. We've got 1 waveform per oscillator, we've got 3 oscillators per voice, and we've got 8 voices maximum, which means the total number of detunable waveforms that you're going to be hearing at any point in time with the Peak is 24. And 24 is a good number. It's a big fat sound that you get with the Peak. Let's look at the Dave Smith Instruments Prophet X next, which is really the Quantum's sort of direct competitor, if you like. Now this is a voice. We'll jump straight to the voice here. We've got 4 oscillators. 2 of them on the Prophet X are called oscillators and 2 of them are called instruments. The oscillators just generate classic waveforms only, and the instruments just play back samples only. But together we've basically got 4 waveforms there, 4 oscillators. Again, same as the Peak and same as the Quantum, the Prophet X has got 8 voices in total, which means we've got a maximum of 8 voice polyphony in total. Now the Prophet X cannot stack voices polyphonically. It'll only do it in monophonic unison mode, which is a bit of a shortcoming, bit of a shame, but the reason for doing that is stacking multiple voices per note that you play, which you then detune, you spread across the stereo field and get big fat monophonic sounds out of it, and that's what we get with the Prophet X. So if we do the maths again, 1 waveform per oscillator, 4 oscillators per voice, 8 voices in total, which means the total number of detunable waveforms that you can hear at any time on a Prophet X is 32. And 32 is a really nice number, and you get some really nice big fat sounds with the Prophet X. Okay, let's talk about the Quantum. This is an oscillator, a waveform generating oscillator on the Quantum. 8 separate detunable spreadable waveforms per oscillator. This is a voice, 3 of those oscillators together with the filters and the modulators all together. That's our voice, and like those other 2 synths that I've just talked about, we've got 8 voices in total, giving us a maximum polyphony of 8. And like the Peak, we've got the flexibility with the Quantum of stacking voices polyphonically on top of each other, and of course the reason to do that is to spread them, to detune them, and get big fat sounds. So the maths: 8 waveforms per oscillator, 3 oscillators per voice, 8 voices maximum. Total number of detunable waveforms is 192. 192. It's a massive, massive, massive number. That is how many waveforms that you can hear if you set up your 3 oscillators with 8 waveforms per oscillator. It's absolutely huge. Okay, so that's enough theory. Let's get back to the synth itself. Now, it's exciting enough that we've got actually 8 waveform generators inside each oscillator that we can detune. However, we can do even more with these 8 waveforms per oscillator than just detune them. We've got down the bottom here, you'll see here, 4 values called semitone 1, 2, 3 and 4. So what I've done is I've turned the detune all the way down to 0 so that we can clearly hear what's going on. But what we can do is set the precise tuning of each of these up to 8 individual waveforms that we choose. We can say the first one will be 0 semitones away from the normal tuning, but maybe the second one we want to set it at a fifth. The third one we want to set it at say a minus fifth, and the fourth one we'll leave as it is, just as an example. So now when I hold down a key, don't hear anything yet because I've only got my one waveform. But as I start to introduce a second one, it's a bit tiring on my ears and probably yours as well because I've got the stereo split wide left and right. So let's bring that back to 90 degrees so it doesn't sound quite so in your face. Let me just do that again. So you'll hear that we've got one waveform at the G that I'm playing here, and then the second waveform is at a fifth above it. Then as we introduce the third waveform, we'll start to hear it at a fifth down. And then as we introduce a fourth, we'll get it at its regular pitch of a G here. Now if you go past 4 and you go into 5, 6, 7 and 8, then the frequencies that those 5, 6, 7, 8 waveforms take will be the same as 1, 2, 3 and 4. So you'll end up with 2 here, 2 here, 2 here, 2 here if you were to choose all 8. I mean, you can create amazingly big fat sounds, and that is just with one oscillator. We haven't even done it with the other 2 oscillators and added those in.